So hello everyone, I've come up with a question of the day. That was also a request sent to me by some student in my YouTube channel. This is from the book Pathfinder for GE Advanced Physics and Olympiads. This is from the topic rotational mechanics, section check your understanding, question number 30. So let us read the problem. A light rod is pivoted at its lower on the ground. The rod is turned to make an angle theta with vertical. That's angle theta with vertical. And a small bead of mass m is affixed at its upper end as shown in the figure. That means look at this figure. You have a bead, a small, no, sorry, this one. This one is the bead at its upper end. When the rod is released, the bead hits the ground in time t naught. T naught, that means this falls to the ground. Time taken is t naught. Now, an additional small bead. Yeah, this I was talking about this. This is the additional bead. I mean, apart from this bead was there in the first case also. In the second case, apart from having this bead, you have one more bead at the midpoint, and that too it is fixed to the rod. Okay, so now let us read the line. Now an additional small bead of mass eta into m is affixed at the midpoint of the rod, and the rod is again released from the same angle theta. Released from the same angle theta with vertical as shown in the second figure. So this is figure 1, and that is figure 2, the second one. Okay, question is in how much time now the beads hit the ground. That means this also the same case. That means this whole rod will be horizontal in how much time compared to t naught. So that's the diagram. Now we will apply work energy theorem to find out the angular speed gained by each of the rod when the angle becomes phi from theta for both the rods. Suppose this angle becomes phi, angular speed omega 1, and for this second one rod also along with the bead at the middle, there also the angle will become phi, angular speed omega 2. Now we will apply work energy theorem. See, half I omega 1 square equal to the loss in potential energy, that is mgl cos theta minus cos phi, right? There is mass only here at the top bead, so that's for case 1. And second one is for case 2. Here also you see half ml square for this plus half eta m into l square by 4. That means half of the length and square of that. So half ml square. I mean I about this hinge in second case, half ml square plus half eta m l square by 4. Omega 2 square is loss in potential energy. There it is mgl plus eta mgl by 2 times cos theta minus cos phi. So we'll get the ratio of the angular speeds omega 1 is to omega 2. So from this ratio of this angular speeds, there is a variation in this angular speed, but you have to find out time, the ratio of the times, right? So see, both these rods have to travel the same angle, right? So the angle traveled is pi by 2 minus theta when it just touches ground. So how much angle it has to travel? Pi by 2 minus theta in both cases. So from there you can consider that the ratio of the angular speeds omega 1 by omega 2 is the inverse ratio of the time. So t2 by t1. T2 is the time taken by so in the second case to fall from the condition given to till the rod falls on ground, and the same time for case 1 is t1. By the way, t1 is given as t naught. So t2, the time in the second case, is equal to t naught times root over of 4 plus eta divided by 2 into 2 plus eta.